Another example of finding the area trapped between curves. So in this problem, they don't give us a graph and they don't give us any limits of integration. So a great way to start this is to just graph this thing and see what it looks like. So doing a reasonably accurate graph here, give yourself 2 in the y direction vertical and then 4 in the x direction in the positive direction. 1, 2, 3, 4. 2 in the y direction. Okay, so our first one is bounded by the x-axis. Okay, I'm not going to draw that line in. We know what the x-axis is. Well, we'll just add that when necessary. So now y equals x minus 2. Well, y equals x minus 2 is the diagonal line shifted down by 2. So it's going to start here at 2 and just go up to 2 comma 4. It's going to keep going onward like that. I kind of cheated and spoiled the punchline here. Okay, so there's y equals x minus 2. Y equals x minus 2. All right, so now the square root of x, well, that goes to 4, 2, and 1, 1, and kind of it looks like sort of a half sideways parabola there. And we know that both of these points, or both of these functions, share the point 4, 2, so we may as well put that in there. And now I can see that the area bounded by this is going to be the area which includes the x-axis here between 0 and 2. So we are interested in this area. And so now we have to ask ourselves, what is the top function and what is the bottom function? Well, it sort of depends where you're looking. And maybe you can see where we're headed here. But if I look at this area, then my top function is going to be the square root of x. And then my bottom function is going to be the x-axis, which is y is equal to 0. Whereas if I look to the right of 2, then my top function is still going to be the square root of x, but here my bottom function is going to be that line y equals x minus 2. So when you draw your picture, it just means sometimes we have to do 2 area integrals. One for the black area to the left and one for the red area to the right. And so let's write that out. For the black area, we're going to use the integral from 0 to, 2? And our top function minus our bottom function is going to be the square root of x minus 0, because our bottom function is y equals 0. To that, we are going to add, well, if I want the black area and the red area, I have to add the red area. So to this area integral, my first area integral, I will add my second area integral. I'm just using that circular plus to just kind of differentiate and keep these two separate here. Okay, so the red area is going to go from 2 to 4 because we're looking, here is x equals 2 and here x equals 4. And that's going to give us the area trapped between those two curves. So what's our top curve in this case? Be careful. Our top curve is still the square root of x minus our bottom curve. Well, our bottom curve is that line, so we need to subtract the line equation, x minus 2. And there we've got ourselves our area. So let's just do this one. All right, I think we've calculated, remembering that this is, this is x to the 1/2. We've done enough of those to just sort of jump straight to the fact that's going to be x to the 3/2 with a 2/3 out in front, evaluated from 0 to 2, plus my red integral is going to give me, again, that same first term, 2/3 x to the 3/2 power. I should tidy this up, minus x plus 2. Okay, so minus x add 1 to 1 over half. What has derivative of x? 1/2 x squared. What has derivative of 2? 2x. All that jazz evaluated between 2 and 4. Okay, and I'm not saying that correctly. Like that's evaluated between 2 and 4. That'd be evaluated at 4. And, right. So let's do some algebra here. Why not? 2/3 times 2 to the 3/2 power plus, all right. Oh, no, don't get carried away. Remember, you got to do the entire thing here. So you got to subtract the 0 guy. So 2/3 times 0 raised to the 3/2 power. Well, that's kind of nice because that's just 0, so we can move on from that one. Plus now it's our red guy. So for x equals 4, we're going to have 2/3 times 4 to the 3/2 power minus 1/2 times 4 squared plus 2 times 4 minus 2/3 to the times 2 to the 3/2 power minus 1/2 times 2 to the 2nd power plus 2 times 2. All right, this all equals, well, I'm going to drop colors now. It equals 2/3 times 2 to the 3/2 power. I'm not going to try and simplify that because I'm looking ahead and seeing that we're going to be able to subtract that guy off. Plus 2/3. This guy right here, I'm going to turn into the square root of 4 raised to the 3rd power. Now we've seen that before, but 4 to the 3/2 power is 4 to the 1/2 raised to the 3rd power, and so that's how you can put that 4 into a square root. Minus 1/2 times 4 times 4 is 16, and we'll just reduce that later, plus 2 times 4 is 8. Now we're here. We're going to start distributing that minus sign. So minus 2/3 times 2 to the 3/2 power. Negative times negative is positive. 1/2 times 4. 1/2 times 4 plus, remember to distribute your negative. Negative times positive is negative. 2 times 2 is 4. Okay, does anything tidy up nicely? Yeah, probably. Most notably, we can just cross out these guys because they're positive and negative being added together. So we've got 2/3 times square root of 4 is 2 to the 3rd power. Minus 1/2 times 16 is 8. Plus 8, that adds to 0. Plus 1/2 times 4 is 2, so plus 2 minus 4, that gives us negative 2, but we'll worry about that next time. So we have 2 times 8 is 16 over 3. 16 over 3 minus, this combines to negative 2, so negative 2 to the 3rd is going to be 6 over 3. Negative 2 over 1 times 3 over 3 gives us negative 6 over 3, which gives us the correct answer of 10/3. And so the area trapped between those two curves, the entire area, because we added together the red area and the black area by doing two separate integrals, is 10/3 units.